Hello, my name is Declan. I'm the solo developer behind Terminal Operator, an indie horror game where the main mechanic is typing. You play as a terminal operator, who would have guessed it, controlling a secure containment facility full of subjects that are really monsters from your terminal using various commands. The inspiration for the idea behind the game was the very common indie game developer advice of making small games. So I set myself the challenge of making a game within 12 weeks by myself. Doing that, I need to cut down on things that I can't do because I just won't have the time to teach myself. The two main things being 3D modeling and animation. So I took inspiration from Five Nights at Freddy's of a game set in one location so that the amount of assets that I do have to use are as limited as possible. Why did I pick a horror game? I took advice from a game development studio called Buy Me Games and their video, The Best Genres for New Game Developers. They talked about horror being a very easy genre to make your first game in. Horror games tend to have a much smaller scope because they have a much smaller playtime. To make a game with 30 minutes of content is a lot easier than making a game with 30 hours of content. The idea behind the typing mechanic was that I wanted a unique mechanic that you don't really see in horror games. A lot of horror games are walking simulators. I wanted to make a typing mechanic that was fun, but also sort of rage-inducing to fit the horror theme. So things like not having the ability to backspace, punishing typos with time, and specific syntax to remember for typing the commands to make typos more frequent. Starting development, I started with this fake terminal asset and this CRT terminal asset, again trying to limit the amount of 3D assets that I have to make. The first thing we had to do was adapt this asset to be on the curvature of the screen. So to do that, a camera sits in front of the terminal text that just prints into the world. The camera casts its output to a render texture, and that render texture is applied to the screen of the asset, and that's how we get this effect. The fake terminal asset had to be almost entirely rewritten. I had to build in my own sort of command logic parsing for the terminal commands, the typewriter typing animation, and text wrapping and text line limits. Creating the map for the facility I used the same idea of the first terminal, making a camera that casts to a render texture that is applied to another terminal screen. So the map of the facility is just made using 3D cubes that are stretched to make the walls. They all use unlit textures, so there's no lighting, so they're all the consistent colors and they look like a sort of mini map on the terminal screen. We hooked up the first commands to the terminal for the map, which were the zoom commands, so now we can zoom into each of the 4 quadrants and zoom out. Then we added a UI label overlays, so you know what each cell is called, what each room is called, which is very crucial for the whole command terminal logic. The UI labels then brought on the second command, which is the labels command, so we can turn them off and turn them on to sort of reduce the clutter on that screen. So the doors were the first sort of challenge in development. Doors were just going to be colored 3D objects that the same as the walls, just cubes that don't touch the walls so that the player can easily tell that they are doors. I didn't want to actually physically move them, so the color, if it's green, is unlocked and red, it's locked. To get the doors working, my original idea was to use a nav mesh. So nav mesh in Unity is baked onto a surface and it basically tells things that are nav mesh agents, so like the player or any AI, that this is the surface that the nav mesh agent can move to. The idea with the doors was using them as nav mesh obstacles, which cut the nav mesh. So cutting the nav mesh means removing the path between 2 sections of the nav mesh. So humans I wanted to represent as sort of blue dots, like they're being tracked on the map. Because of the zero lighting in the map, making a light, they have to have something to reflect off of. So the humans were just planes that float with a blue light above them. So on the map, they just look like blue dots of like a flashing light sort of thing, which you can see here. Implementing the navmesh agent should be easy. Navmesh agents work with, you have a navmesh agent, you tell the agent where to go, it moves there. You don't have to do any complicated maths, no pathfinding. Should be easy. This turned out to be not easy with the door cutting off the navmesh. The navmesh agent doesn't have a path to that room anymore. So instead of waiting at the door like you intuitively think they should, it doesn't know anything about the door or the wall. It just knows the navmesh doesn't go past this point. So now instead of walking to the door, the navmesh agent walks into the wall at the closest point to the navmesh that it's trying to reach. Obviously, not what we want. Doors now can't cut the navmesh because now we need to keep the path through the door existing, essentially. So we need to come up with a different logic for stopping the humans when the door is locked. So doors aren't navmesh obstacles anymore. So now there's nothing preventing the human from walking through a door because the door is just nothing to it. So now, instead of the navmesh obstacle cutting the path, doors have script on them which keep track of their lock state. So if they're locked or unlocked, and now humans collide with the doors, check if what they collided with is a door, check if the door is locked. If the door is locked, the human waits in place, waiting for the door to be unlocked. The problem here now is the humans can walk through the door. If the collision of the human and the door is not happening an infinite amount of times, there are parts of times where the human can walk through the door before the collision is registered. So now humans have an invisible collider ball which in front of them that checks a certain space in front of them for the collision. Now we need a way for humans to communicate that they need a door unlocked to the player. Using this asset we found on the Indie Asset Store, this is the most 3D modeling I did. I separated this speaker from the PC from the rest of the asset, and the keyboard and mouse. So now the scene has a little bit more to it, and we can use this speaker as an intercom sitting between the two monitors. We also use this speech bubble asset for pop-up messages to appear as it's, again, to save on development time. I don't have time to voice act or get voice actors for all these lines. So just having them be text on the screen is a lot easier. The intercom is hooked up to the door request, so when a human AI collides with a door, it stops, it waits for the door to be unlocked, and it sends an intercom message to the player saying, hey, can you unlock this door? Doors now also need to store the room that they are the door to. So in order to have the intercom messages be relevant to what, and tell the player what door they are, doors need to keep track of that information. With a bit of regular expression magic, we can make some semi-dynamic intercom messages that autofill with the context of the door. So I can write as many lines here as I want of different wording for the door requests, and all these functions will input the door ID into the given line. So now we actually get into a very core part of the game, the monsters. Implementing the monsters physically are the same as the humans, but just red. So the plane and the light, both just red instead of blue. To begin with, the monsters just had random pathfinding on the navmesh. They picked a random spot on the navmesh, walked to it, picked another spot. Very simple, boring artificial intelligence. And it was changed very quickly. The only other logic the monsters had at this time was killing humans in a certain range. So we just cast a sphere every so often over the monster, and if a human is in that sphere, the human dies. The monster pathfinding obviously needs a little bit more complexity than just picking a random spot in the whole facility. They need to know where they can access. So if they're within their cell, they need to know that they can't leave the cell. They need to know that there's the only location they can pick a destination from is the certain room that they're in. So now we have room zones. So room zones are these invisible bounding boxes for each room. They keep track of the occupants in each room and the doors that are connected or lead to this room. So through that we can check if doors are locked or unlocked, and now we have some sort of logic for checking if a certain entity is in a room, if it has access to another room on the other side of the facility, we can check through the room zones and through the connected doors. For our room finding logic, we also now need the doors to keep track of the two room zones that they separate. So the room zone on one side and the room zone on the other side. So now that we have logic to find the accessibility of different rooms in the facility, the monsters can be revamped to know that if they are in a cell and they're in a room, the door that connects to that cell is locked, that the only accessible room zone they're in is the one that they're in. So the pathfinding now only finds a point to move to that's in all the connected room zones that it can access from where it is right now. So now that we've got this logic, monsters no longer give themselves random points in the entire map, and they can actually be confined to their cells. Monsters contained in a cell will just walk back and forth. If a monster's cell door is unlocked, but the cell block is still locked, it can go anywhere in the cell block and any unlocked cell in that cell block. Monsters now also determine if they're escaped. So for a monster to be escaped, they have to have access through the same room logic into the hallway. The hallway has access to this point on the map here, which is the entrance to the facility. If a monster has access to that, they will prioritize reaching this exit over killing and hunting humans. They will still kill humans that run into their range, but they are smart enough to prioritize escaping the facility over killing humans. If they have no access to escape and there are humans within the room zones that they can access, they will they'll hunt and kill any humans in the connected rooms. So now we need a way to stun monsters if they're contained but outside of their cell. So like I said before, if a monster's cell door is unlocked but their cell block is still locked, they roam freely in that cell block and their cell. We need some sort of way for humans to put monsters back in their cell, but we know if humans go up to monsters, they just die. So we now have this gas command, which beautifully links up with our implementation of the connected room logic by gassing adjacent rooms if doors are unlocked. So gassing one room will gas that room and rooms that it has access to from that room. Gas stuns monsters for a period of time or indefinitely if the gas is still active. So if a room is no longer gassed, the monster starts a timer to become unstunned and returns back to its normal logic. Gas also instantly kills humans, so if they're exposed to it, so there's the added risk of gas spreading through open doors that adds a little bit of an extra layer to the gameplay. We also need a way to remove the gas, so we also have the vent command, which does the opposite of gas. It removes gas from a state in the room, and will obviously then begin a timer for the monster to become unstunned after a period of time. Now, this doesn't really touch on the logic of how do we move the monster from where it shouldn't be to where it should be, but we'll get to that next. So you're probably wondering what this EXT room is, this extermination room. So next we added the Purge command. The Purge command kills everything in the extermination room, and that's it. It's pretty simple. So now we need a way to move monsters around the facility. So you can see this cyan track around the outside. It's mainly to move monsters from their cell to the examination rooms and the extermination rooms. So this cyan track is simply a nav mesh of its own on top of very thin rectangles with a bunch of destinations outside of the cells in different rooms, which tells the transport system which room it's connected to. Next, we add this for the transport system, this carriage. This carriage is what transports monsters and it can be controlled by TS commands from the terminal. So we can move the carriage to different rooms and we can load and unload stunned monsters. There was an implementation of a sort of distressed state in the previous human logic where if humans would be alerted to escaped monsters. So if a monster was hunting a human, the human would become distressed and start panicking and running around. The problem was it was just picking a random spot and moving to it. They're basically the same implementation for the monster's logic originally. This meant that there was a good chance that if a monster was coming down the hallway, the human would try escaping by running to a point that is behind the monster, so the human would just run straight into the monster. doesn't really work. So now our new reformed distress state for the human finds a valid destination that isn't the current room, the previous room, or any of the cells. So it's not perfect, but it does the job most of the time. You don't really notice the human running into the direction of the monster as much. It sort of finds a room further away most of the time. Distressed humans also now don't stop and wait at locked doors. They request for them to be opened before leaving quickly. So they don't, like the normal door requests, they don't do them again. They just do them once and then they wait for about half the time and then run away. The Intercom now also has a distressed speech bubble for humans' door requests while they're stressed. It sort of provokes a little bit of urgency in the player. Humans can also now freeze in fear briefly before going back into distress from distress. So next on the list of game mechanics is the task system. The task system is pretty important to the whole gameplay logic of the player controlling the humans to some sort of degree. We mentioned before the gas and vent system was implemented to fix the issue of how do we move monsters from rooms they're not meant to be in, into rooms that they can be in. So that goes hand in hand with the transport system. The transport system can move monsters from rooms that the transport system connects to. But we also have the problem of the cell block rooms. The transport system doesn't connect to that. So we needed a task for humans to pick up stunned monsters and move them to their cell. There's two kinds of tasks in the game. So we have these default behavior tasks that humans do when they have nothing to do. So before they were just picking a random spot that they could walk into it for a few seconds and then walk into a new spot. These spots were random, so it could just stop in the middle of the hallway and it would look really stupid. So now they have actual destination tasks and they walk between them, do the tasks, and doing the tasks they just stand there for a random period of time. The other tasks that we have which are more important are user assigned tasks. So user assigned tasks take priority instantly and interrupt non-user tasks. User assigned tasks are assigned by the task command. The first of which we implemented is the examine task. So examine tasks make use of the examination room. Examine tasks require a stunned monster to be in the examination room. So the task itself, assigning it to the human, is relatively simple. It's just task examine. The human will know to go to the examination room and inspect the monster for a period of time before leaving back to a non-user assigned task. The thing that makes this a little bit more complex is that the player needs to know to gas the room that the monster is in, move it using the transport system to the examination room, assign the examination room task before the monster wakes up, then lock the door after the human leaves, gas the room again, and then move it back to its cell. The time it takes to do the examination task is obviously a lot shorter than the time monsters are stunned by, because the monster has to be recovering for the human to enter the room. And that brings us to the end of the first 4 weeks of the 12-week development of Terminal Operator. I'm about 11 of the 12 weeks into development, so the game is almost done, and a lot of what you're seeing right now in this video is from the current state of the game. Terminal Operator has a Steam page, and you can go wishlist it right now. The game will also be appearing in Steam's Scream 4 Fest, which begins this Monday. A demo of the game is under review right now, and fingers crossed, hopefully, will be available to play for the duration of the festival. If you've enjoyed the video, please consider wishlisting the game on Steam and subscribing to the channel. There will be 2 more devlogs on the development of this game, covering the 2nd and 3rd month of development. You can go follow the development on all the social media down below, and thank you for watching.